All right, we started the recording and then we'll go ahead from this point. So last as we talked about up to the second row that we found out that whenever for the second row, we're going to have this situation that we have the S1, S2 closed and open. So one of the key part that you need to understand that as long as the switch S2 is closed, the current that will pass through the heating element A will actually pass through this switch and eventually go back to the source. So B will not be a part of the circuit. That is the key part. So up till now, we don't have any problems. This was 1.5 kilowatt. And for the third row, we had closed. So we have S1, S2, S3, all three of them closed. So this one for the third row, only this one and this one will be in effect. Both of them will be getting full 240 volts because they'll be directly connected parallel to the supply. So 1.5 plus 1.5 gives you 3.0 kilowatt. So you don't have to write the units over here. Forget about the units because the unit is already given. So 3.0 is for this one. Now comes the interesting part. Have a look over here for row number 4, closed, open, open. Now try to understand this part. Let me just erase those things on my figure. Can I not erase these things? I should be able to erase these stuff. What happened to you? Why can't I erase this? Yes, delete. So let's have a look at row number 4, closed, open, open. So in this case, this means the switch AS1 is closed, this is open, and this is also open. So currently the current has to pass out in this pathway. Now what you need to see that both of these two heating elements are in series with each other because this is how the current is flowing. So this 240 volt supply will be divided across this. So this is going to get 120 volt and this is going to be 120 volt. They're definitely going to have some power, but we have to calculate out how much that power is going to be. Now remember this equation. The power of any electrical component can be expressed by P equals to V square by R. The reason I'm choosing this expression because we are having a change of the effective available voltage to these heating elements. Earlier it used to be 240 volts full. Now it is only 120 volts. So if we also calculate the resistance of this components over here. How much was this value? Can someone tell me? A resistance valueটা কত আসছিল? আচ্ছা, anyway, to be honest, we do not need this resistance. We can directly go ahead to use the proportionality because what you can see over here that as long for whatever the current that flows to here, the resistance for each of these heating elements can be considered to be a constant, which tells us that power would be directly proportional to the voltage squared. So if I just write that P1 by P2 equals to V1 squared by V2 squared, this relationship is the equation expression for this proportionality. How does that help? Originally, if we could provide 240 volt to the power heating elements, their power is supposed to be 1.5 kilowatt. That's our P1 V1. That's our given values. Now for one heating element we are only providing 120 volts, so 120 square, and we are trying to calculate what would be the new power. এটা হিসাব করে দেখো এই নতুন পাওয়ারটা কত আসে. Try to have a calculate of this one and figure this out. You'll find out this will become 0.375. ক্যালকুলেট করো, এটা ক্যালকুলেট করে দেখা কত আসে. Gives us 0.375 kilowatt. So one of these heating element will give us a power of 0.375 kilowatt. We have such a drastic loss of power because of the lower voltage that we are able to provide for the series combination. One of them has a 0.375, so this one will also have the same 0.375. So the total power of the whole heating combination, that part which is working, would be the sum of these two, which is basically 0.75 kilowatt. So the answer to this question is 0.75 kilowatt. এই লাইনটা বুঝাই হচ্ছে ইম্পর্টেন্ট. This is a difficult line to work with. See if you can make sense of this one. এই পার্টটা বুঝা গেছে কিনা, এই লাইনটা বুঝা গেছে কিনা? Is this clear to all of us? Hello? I hope it is. The last row is actually pretty simple because this is just a this is just an outcome of the fourth row. It says closed, open, closed. So if I just once again have a look at the circuit and prefer to erase all of the earlier drawings and everything, and all of these drawings, get rid of these things as well. This one says closed, open, closed. So the way it will work is that this one is closed, this is open, and this is closed. So basically now the current can flow through these two branches who would be in series, and the current will also flow through this whole thing. You have to see that these two combinations are in series, so they are going to be getting half the voltage of the supply, pretty much like what happened over here. Additional to their heating effect, we're also going to have some heating effect of this switch, this heating element C, which happens to be in directly connected to the supply. You can have a look that current can directly come over here, and the current can directly get away from out of it here as well. So together this will have the whole power of 1.5 kilowatt, no big deal. And the common power of these two while in series was calculated with 0.75. So if we add up the total power of the whole heating combination, this will be 1.5 plus 0.75, ultimately leading up to 2.25 kilowatt, which is gonna be coming up over here. Interesting enough, this table only had 5 marks in it, and there is no credit given for showing the calculation. Only the correct numbers in the proper places can give you this mark. If you have a look at the mark scheme for this question, there can be some pretty interesting stuff. Let's have a look at the mark scheme for this one. This was question number what? This was question number 7. So have a look. They have simply given these 5 values, and that's all that mark that you get. And in the examination report, they have given us some interesting stuff. It was surprising that a significant number of candidates did not seem to realize that when switch S1 is open, there will be no current in the circuit. More able candidates usually successfully come to the table. The majority of candidates appear to have difficulty in deciding which elements would be operating when switch S2 is open or closed. So it is the position of the switch 2 that was actually the deciding factor for which people could score full marks and which people could not. So that's pretty much it for this question discussion. We're going to move on to the next one if you don't have any question. If you cannot use your voice chat, you can write questions in the chat window, no problem. I can pick it up from there as well. The next one that I'm interested to discuss for within this worksheet is actually this one. Is it this one? Yeah. Let's look at question number 11. I'll take out the necessary parts as required out of the PDF, but for the timing, let's have a look what we have over here already. Figure 6.1 shows the variation with the applied potential difference V of the current I in an electrical component C. State to the reason whether the resistance of C component increases or decreases with the potential difference. So you're simply going to write resistance decreases because the gradient of IV graph increases. That's it. Do not mention that gradient of IV graph is 1 by R. If you mention that, you're going to immediately lose that mark. Determine the resistance of the component C at a potential difference of 4 volt. So 4 volt is the current 2 milliampere. So you just use those two numbers. Be careful that there is a milli over here. So be careful to include this in your calculation and get the resistance out of it. That part is pretty simple. In B, it says component C is counted in parallel with the resistor R of resistance 1500 ohm and a battery of EMF E and negligible internal resistance as shown in figure 6.2. We have the source, we have this heating element C for which the graph was made available, and there is a 1500 ohm fixed resistor. On figure 6.1, draw a line to show the variation of potential difference V of the current I in resistor R. First thing they're asking us, we have to draw a line to show the variation potential difference V of the current I in the resistor. So we have to plot the graph of this 1500 ohm resistor on this graph. How do we draw that? Drawing the graph is practically actually very, very simple, and it doesn't cost much trouble. Let me show you this. So we are trying to draw the IV graph for a fixed 1500 ohm resistor. It's very simple. I'm saying it to be very simple because you have a lot of different voltage values over here. You do understand this straight line will definitely start from the 0 point. I mean, applying 0 volts would always give you 0 current. Although you have to find out that for one of the relevant values of voltage, you can choose any of the values over here. What would be the current value? Well, I'm gonna draw this whole graph to the enter the across graph available. So I'm trying to choose 6.0 volt and see how much current do we get. So if I use the Ohm's law, V equals to IR, and if I try to calculate the current out of it, I equals to V by R, which gives us 6.0 divided by 1500. And interesting enough, you'll find for this question, for this value to be exact is 4.0 in 10 to the power minus 3 ampere, which basically is 4.0 milliampere. So this tells us that one of the starting point for this straight line should be the 0 point. The other one should be the very last corner, where the 6 volt applied volt would be 4 gives us 4 milliampere of current for this 1500 ohm fixed resistor. Now we have to draw this line, so I'm going to try my best to draw a straight line, which I don't know how to draw pretty well within this graph, but I'm going to try anyway. So let's say we're going to have a graph that looks somewhat like this. This is supposed to be a straight line. You can draw it with your ruler, and you should draw it with your ruler and draw this up, and this is the straight line that you have. And then comes the interesting part of the remaining question. It says that hence or otherwise use figure 6.1 to determine the current in the battery for an EMF of 2 volt. Now have a look. If you have a look at this circuit, let me take this out. If you have a look at this circuit, you will find that within this circuit, these two components, C and 1500 ohm, they are actually connected in parallel to each other, which means the same EMF of the supply would be applicable to both the components. And the current that it will be pulling and the current that it will be pulling, they would be summed up over here. So a large current will come out for both of them, and they'll individually break down into two different branches and flow through the branches, and eventually merge over here and get back to the supply once again. The question tells us, what is the question asking us? The question is asking us, hence or otherwise, use figure 6.1 to determine the current in the battery for an EMF of 2.0 volt. So which means when the EMF of the battery is 2.0 volt, what will be the current that this source will be handling? So the total current is being asked. It is very simple to solve this question just by looking at this graph. Have a look. Whenever the voltage supply is 2 volt, the heating element C, or this not heating element, this element C is going to be pulling out from the battery this much current. So we have to plot this graph all the way up over here, and we get about here, which is nearly 7.5 division over here. I can write this as 0.75 milliampere. And if you draw this graph carefully with a straight line, you should also be getting a perfectly fixed number as you come up over here. What is the intersection point of this 2.0 for a straight line? Can somebody give me the straight line value? What is the actual true intersection of this 2.0 volt for the straight line? Hello, Fayaz or Zara?
দাঁড়ান এক সেকেন্ড দেখছি।
আচ্ছা, একটু একে দেখো, একে আমাকে বলো।
প্রথম তো ওখানে 5.3 3.5 এ আসে।
কত আসে?
গ্রাফ থেকে যেটা ওটা 5.3 3.5।
Hold up. We are not trying to calculate the voltage for 2 milliampere current. We are trying to calculate the current for 2 volt. This one is 2.0 volt. We are given this value. So what we are trying to do is we are trying to find out the intersection on the y-axis for the 2.0 volt value. I mean, এটা আরো অনুমান করছি because this is already given. I want to know what is this intersection value is exactly. Do we get 1.3 or somewhere 1.4 or 1.35? So what do we get?
1.36 এর মতো স্যার, একটু বেশি বাট 1.3 এর মধ্যে স্যার।
মানে 1.3 আর 1.4 এর মাঝখানে, তাই তো? মানে did you draw this straight line?
একটু দেখা হয়েছে বাট জি ওই 1.35 এর মধ্যেই, সো 1.3 বলা উচিত।
আচ্ছা, let's say 1.35 ব্যাপার না। So if we get somewhere over here is 1.35 milliampere. So this essentially means whenever 2 volt is applied over here, this component will be pulling this much current. So এই branch আমাদের flow হবে হচ্ছে 0.75 milliampere, আর এই branch flow হবে হচ্ছে 1.5 ampere. So the total current that will be coming out would be the sum of these two values. So you're simply gonna show and write these two values, and you're just gonna show the addition of these two numbers over here, এবং এক্সামিনারকে বোঝানোর জন্য to make sure that to make the examiner understand that you understood the problem properly, I highly recommend that you draw these intersection lines over here. You don't have to label these values, but preferably draw this intersection line so that the examiner would know that how did you use the graph, because the question says that hence or otherwise use figure 6.1 to determine the current in the battery for an EMF of 2.0 volt. So if we only sum up the value and write over here, you are actually not leaving any trace on the graph to represent how did you actually solve this problem. So it's better if you leave these trace lines over here, which is I appreciate this very much. বুঝা গেছে?
জি স্যার।
Achha, so this was one of the questions that I really wanted to discuss, and these are not very difficult questions, but there are some nicks and crannies that we need to take care to if we want to score really good marks. This is another question for the Kirchhoff's law. I would like you to just attempt this on your own, and so that you can do this later. I'm trying to figure out some unique questions which would be difficult for you to solve, maybe. Uh, Acha, I would like to discuss this problem. Have a look. Number 17. Turn up to question number 17, and I'd like to discuss this. There is a theoretical aspect to this question which needs some attention. Two resistors, each of resistance R, two resistors, each of resistance R are connected first in series, then in parallel, so that the ratio of common resistors in current in series divided by common resistance of resistors current in parallel is equal to 4. So this is the part that we're trying to achieve. Acha, এক সেকেন্ড আমি একটু আসতেছি। So this is actually pretty simple. You just have to do that, show the calculation R plus R equals to 2R, R inverse 1 plus R inverse 1 whole inverse equals to R by 2, and then you show 2R by R by 2 equals to 4. এটা দেখালেই হবে। এটার জন্য 1 মার্ক, কারণ এখানে অ্যাকচুয়ালি কোনো মানে আহামরি কিছু করতেছো না তুমি, just showing some basic calculation. Number B says the variational potential difference V of the current I in a lamp is shown in figure 6.1. So this is a current versus voltage graph for a filament lamp or lamp for the matters, and we can see that decreasing in parallel, representing that the resistance is increasing with increased voltage and increased current. Calculate the resistance of the lamp for a potential difference across the lamp of 1.5 volt. 1.5 volt হচ্ছে এই জায়গায়, এখান থেকে ট্রেস আউট করে তুমি কারেন্টটা বের করবা, have a ratio of these two numbers, you get the resistance. রেজিস্ট্যান্সটা ক্যালকুলেট করো, এখন ক্যালকুলেট করে দেখো কত আসে। খেয়াল করে এখানে শুধু অ্যাম্পিয়ার দেওয়া আছে, সো মিলিটিলি নাই, এটা দেখো কত আসে, বের করে ভ্যালুটা বলো আমাকে।
এটা 15 ওহম না?
বলো কত আসছে।
15 ওহম। স্যার
বলো
15 ওহম।
এক্স্যাক্টলি 15.0।
জি স্যার।
এখানে তো সব 2s দেওয়া, সো শুধু 15 লিখলে সমস্যা নাই। ওকে, আচ্ছা, এরপর আমাদেরকে বলছে সি নাম্বার বলছে two lamps each of having IV characteristics shown in figure 6 are connected first in series and then in parallel with a battery of EMF 3.0 volt. সো আগেরটা কিন্তু আমরা হিসাব করছি 1.5 ভোল্টের জন্য, খেয়াল করো। So they are current in series and then in parallel for 3.0 for negligible internal resistance. Complete the table of figure 6.2 for the lamps to current in the battery. So I'm going to need this graph to discuss this question and to fill up that tab as well. So let's go ahead and take this out. So having this graph, expanding it a little bit, and then the remaining part of the question is right here. So actually we could use a much bigger version. So let's take out this whole thing and place it on the side so that I could do my writing at the bottom. Okay, let's have a look. কোশ্চেনটা দেখা যাচ্ছে সবার নাকি একটু বড় করব?
স্যার
আচ্ছা ঠিক
আরেকটু
আছে।
বড় করলে ভালো।
একটু বড় করলে ভালো হয়। ওকে, অ্যাকচুয়ালি আমার ডান দিকে এখানে পড়ে গেছে হচ্ছে তোমাদের পার্টিসিপেন্ট লিস্ট। আচ্ছা আমি এটা নামা রাখতেছি, তোমাদের কিছু বলতে হলে হাত উঠায়ও বা হচ্ছে আমাকে সরাসরি বইলো। আই এম ইউজিং দ্য ম্যাক্সিমাইজ ভার্সন অফ দিস হোল থিং, সো দ্যাট কেস ইজ ইউজেবল। লেটস হ্যাভ এ লুক। Alright. Two lamps, each having the IV characteristics shown in figure 6.1, are connected in series and then in parallel with a battery of EMF 3.0 volt and negligible internal resistance. Complete the table of figure 6.2 for the lamps connected to the battery. Now have a look. Try to understand. We have a source of 3.0 volt. Try to imagine the circuit in your head. Try to imagine the circuit in your head. We have a source of 3.0 volt. Let's say we connect two of these lamps in series. Whenever we connect them in series, each of them are going to get a voltage of 1.5 volt because voltage should be shared between them, which means the current pulled out would be very much similar what we calculated over here. So for 1.5 volt, the pulled out current would be 0.10, and for that scenario, the resistance of one of those bulbs would be exactly what we calculated earlier. What was the calculated value for the earlier? 1.5 divided by 0.1 gave you 15 ohm. So whenever the lamps will be connected in series, the PD across each lamp is going to be 1.5 volt. Resistance of each lamp is going to be 15 ohm. Common resistance is going to be 30 ohm. এটা বুঝা গেছে কিনা দেখো। Acha, think about it. Whenever we're going to connect them into parallel, now imagine the circuit slightly changed. We have the source and we've connected both of the lamps in parallel to each other. So they are connected in parallel combination, which means each of the bulb are getting perfectly 3.0 volt. Each of the bulb is getting 3.0 volt. So PD across each lamp would be 3.0 volt. রেজিস্ট্যান্স অফ ইসলাম কত হবে সেটা এখন আমাদেরকে এইখান থেকে বাই করতে হবে। হ্যাভ এ লুক, 3.0 ভোল্টের জন্য আমাদের কারেন্ট হয় কত? 0.15। দেখছো? তাহলে এখন এই 3.0 আর 0.15 কে ইউজ করে আমরা V equals to I R ইউজ করে আমরা রেজিস্ট্যান্সটা ক্যালকুলেট করি। R equals to V by I, which gives us 3.0 divided by 0.15, এটা আসবে হচ্ছে 20 ohm. So resistance of each lamp হচ্ছে 20 ohm. Combined resistance of the lamps হবে হচ্ছে 10 ohm because they are connected in parallel. So 20 inverse plus 20 inverse whole inverse gives you 10 ohm. এইটুকু আসলো। Then D তে বলছে use data from the completed in figure 6.2 to calculate the ratio common resistance of the lamps connected in series divided by common resistance of the lamps connected in parallel. So এটা আসবে হচ্ছে 30 divided by 10 gives you 3.0, preferably right 3.0. Don't only write 3 because 3 is a 1SF number. Write 3.0 is a 2SF number. Minimum 2SF is required. Now comes the interesting question for which we discuss all of this part. This is the important question in my head. You can star mark this question for future revision. It says the ratios in A and D1 are not equal. By reference to figure 6.1, which is this one, and state and explain why qualitatively the change in resistance of a lamp as the potential difference is changed. So 6.1 is this one. Here we calculate that for fixed resistors, whenever we have a ratio of this one, this ratio used to be 4. But whenever we had this one, this ratio came out to be 3. The question is asking us that why there is a change, and we have to use reference from the 6.1 graph, which means essentially we have to mention some property of this graph to be able to answer this question. We have 3 marks in it. This is the important bit. This is the whole this is the reason I'm taking this question so seriously, because there is 3 marks in it. 3 marks in a 60-mark exam is big. So let's have a look. Well, we do understand that whenever filament lamps are connected in series, their common resistance lowers the current and lowers their individual voltage availability. So they have a much smaller resistance because the graph is quite steep. But whenever we connect them in parallel, each of the bulbs gets the full supply of voltage. So they essentially experience a much higher current and they heat up more and they get more resistance because the gradient of the curve is less for high voltage and high current. We're not saying that the gradient of the curve is resistance. We're saying that resistance is more because the gradient of the curve is more. That's the type of wording you need to write. So this is the whole content of this whole question, that at series we have less voltage because voltage is getting shared, less voltage, less current, and we are at the higher gradient segment of this graph. So less resistance, and in the more part we have more resistance because the resistance is more for the parallel combination. That's why the ratio has a different value. For fixed resistor we didn't have this problem. Fixed resistors essentially mean that no matter what voltage or current that we use them with, they are going to maintain their resistance at that very precise value. But that's not the case for these lamps, because you can see that in the IV graph we are losing gradient, which means the resistance is essentially a variable. এটা হচ্ছে এই কোশ্চেনের কন্টেন্ট। To make better sense, I'm going to have a look at the mark scheme and I'm going to try to explain the mark scheme in the examination part of this question as well. So if we have a look at question number 17, here we are. We have these numbers filled up and then say this is the question, that is resistance increases as potential difference increases. Increasing PD increases current. Current increases non-linearly, so resistance increases. So they only use the term non-linearly, so resistance increases. This is not, in my opinion, is not a good enough explanation. In my opinion, see, that is non-linearly explanation. A non-linearly change could also be increasing gradient. But I would appreciate that you say that the current increases with a decreasing gradient, so the resistance increases. Don't only mention non-linearly. Non-linearly could be either decreasing gradient or it could be also increasing gradient, but you have to specify what gradient change is happening over here. So preferably write what is the type of change of gradient for this graph. The examination report says over here, the calculation of the ratio was very straightforward. Although most candidates realized that the resistance would increase and the potential difference decreases, very few attributed this change to the nonlinear increase of current with potential difference. Frequently, the answer was a statement without any explanation. So you do understand that this was the problem. This is a 3-mark question, so you need to be careful what you're writing. The main thing is you have to mention that for the filament lamp, as voltage and current goes higher, its resistance increases because of the decreasing gradient of the IV graph. And then you slowly structure your question. First, you can first state the reason from the graph. What is the property of the graph that you're seeing at the on the graph? Mention that and use that reason to construct your answer for the next 2-3 sentences.
স্যার
Yes.
স্যার প্যারালালে যখন আমরা কানেক্ট করছি তখন তো কারেন্ট ডিভাইড হয়ে যায় না, তাহলে কারেন্ট বাড়বে কেন কি স্যার?
The current that comes out of the battery, that becomes divided, but doesn't that current by itself become double? Actually, not double. Doesn't it increase? Have a look. Whenever we have a battery of a fixed EMF, if we have two bulbs connected in series, the amount of resistance that you have over here is something. It's pretty high resistance compared to if we have two bulbs connected in parallel. The common, sorry, if we have two bulbs connected in parallel, isn't the common resistance of this parallel combination significantly lower compared to the over here?
ইয়েস স্যার।
So essentially এখানে the amount of current that will be coming out from this battery for this place would be far too smaller compared to the current that pulls out from this place. You have to understand that this bulb pulls his own current and this bulb also pulls his own current, and this pathway up to this much and up to this much basically carries the sum of their current required. So we have a very large current to begin with, which gets divided. It's not that the same. It's not that this same current is available over here. We have a far bigger current available over here.
বুঝেছি স্যার, থ্যাংক ইউ স্যার।
Beautiful. So এটা বুঝা গেল। ফায়াজ বুঝছো এটা প্রপারলি?
স্যার
আচ্ছা পরেরটা দেখি। Just a second. We start the recording, so let's go ahead to find out a new problem that we have to go for. I want all of you kids to, the two of you, all of you, okay, to attempt this question. Question number 18B. 18 B তে কার সব কিছু অ্যাপ্লিকেশন আছে এটা ট্রাই করো একটু. I'll give you some time. If you can solve it and answer doesn't match, I'll help you. So pause. 18B. So using the recording, I1 is coming in here, I2 is leaving this way, I3 is coming in here, and I4 is leaving this way. So you can see for this junction, you can judge any of the junction, doesn't matter. I1 and I3 are the incoming currents, I2 and I4 are the outgoing currents. So I1 plus I3 equals to I2 plus I4. That's your current equation for Kirchhoff's first law. Then it says the relation between E1, E2 R and I3 in the loop NKLMN. So let's first find that out. NKLMN. So this rectangular loop we are considering. Forget about the sideways. We'll start from N. And if as we go from N to K, we see that our considered loop direction is opposite to the current. So minus I3R. Then K to L, nothing. L to M, nothing. M to N, nothing. So that's it. Minus I3R, NKLMN, NKLMN. So we only have one resistor component equals to, now we have to go to look for the EMF. This loop direction that we're considering is the preferable direction of current to be produced by this one, because this is positive and negative. This will try to produce the current like this, whereas this one will naturally try to produce the current in the other way around. So this one is counted as the positive EMF, and this one comes out as a negative EMF, E1 minus E2. And that's basically your equation. You're done. For the third, now question number 3, between E2R, I3 and I4 in the loop NKQN. So NKQN, NKQN. So we are going this way. So we are going this way. This is the loop direction. This is the loop direction. NKQN, this right triangle that we're dealing with. So if we go from N to K, once again we have minus I3R. And then from K to Q, we have minus IR4R. And then for Q to N, we also have minus IR4R. And then if we go from N to K, so that's basically the whole potential drops. And then for the EMF direction, you'll see that for this loop, this battery is going to try to produce the current in this manner, because this is a positive and this is a negative end, whereas our considered loop direction is opposite to that. So we're going to write minus E2. You might feel like that we have so many minus in this equation, is it going to be a problem? But the answer is solid no. You can keep your equation like this, you're going to get full marks for it. But if you feel like it, and if you have enough space over here, you can simply do this minus 1 multiplication on both sides. And because you have 2 minus I4R, you can also add these up. That will ultimately lead into I3R plus 2I4R equals to E2. So if you finish right here, it's perfectly all right. If you want, you can do this. This is optional. বুঝা গেছে?
Yes, sir.
Sir,
বলো।
sir, can you repeat part 1?
This one?
Yes, sir, just explain.
Sure. To find out the relationship between the currents, you have to find out one of the junctions where all the 4 currents are relevant. You can see that I1 is coming up over here, it is reaching up over here. And from this junction, we have the pathways for I2, I3, and I4. So using the notation that was already given in the question, let's say I2 was given over here. I brought the I2 right over here. I wrote it over here for a better visualization. I3 was given upwards, so I wrote I3 over here as upwards for a better visualization. I4 was going down way because this was given over here. I wrote it over here once again for a better visualization. So I can see over here for this junction N, I1 is the incoming current, I4 is the I3 is the incoming current. These two are incoming, and I2 and I4 are leaving or outgoing current. So sum of incoming current equals to sum of outgoing current. That's it.
Thank you, sir.
No problem. Let's try to find out the second problem that we can try and solve. I want you to try number 19, all of it. I'm interested in number C precisely, but to be able to do number C, we have to do all this calculation. So get a go on for number 19. I'll give you some time. So C number will say, question number C says, a second heater also designed to operate from a 12-volt supply is constructed using same actum wire, but using half the length that calculated in B. Explain quantitatively, this is the important word, explain quantitatively the effect of this charge change in length of wire on the power of the heater. Now, here's the deal. If I just copy this and take it out, what you need to understand সেটা হচ্ছে আমাদের একটা কন্ডাক্টরের রেজিস্ট্যান্স ডিপেন্ড করে লেন্থের উপর in the relationship R proportional to L. So when the L will be halved, the resistance will also become halved. Half the resistance will essentially cause the current to become double because the voltage supply is remaining the same. So it means that if you consider the formula P equals to I square R, here the resistance has become half and the current has become double. So basically this is 2 squared multiplied by half. So ultimately you get 2. So what I'm trying to show you over here is that the total effect of using half the length would that be that the resistance will become half, but the current will become double, and because there is a square on top of the current variable, that's why the altogether the power would simply become doubled. সো এই জিনিসটা তোমাকে এখানে কোয়ান্টিটিভলি দেখাইতে হবে। কোয়ান্টিটিভলি দেখানোর মানে হচ্ছে আমাদের আগে যে ইকুয়েশনগুলো আছে সেই ইকুয়েশনগুলো ইউজ করতে হবে। কিভাবে ইউজ করতে বলতেছি, এখানে বলছে শো দ্য রেজিস্ট্যান্স অফ দ্য নাইট্রোমার ইজ 2.4 ওহম। সো প্রথমে আমরা যে কাজটা করব সেটা হচ্ছে আর নিউ ইকুয়ালস টু 2.4 ডিভাইড বাই 2 ইকুয়ালস টু 1.2 ওহম। তুমি লিখবা বিকজ আর প্রপোর্শনাল টু এল, এইটা হচ্ছে রিজনিং। তারপর তুমি লিখবা হচ্ছে আই নিউ ইকুয়ালস টু 12 divided by 1.2 equals to হচ্ছে 10 ampere. Therefore power new equals to 10 square into 1.2, এখান থেকে যা আসে এটা আসবে। সো এখানে পাওয়ারটা আসবে হচ্ছে আগেরটার ডাবল। এটা হিসাব করে দেখো তো কত হয়, 100 1200 100
120 volt.
120 না,
Yes, sir.
120 ওয়াট। সো এটা
স্যার
120 ওয়াট।
এটা আরেকবার বুঝাবেন?
কোন পার্টটা বুঝে নাই বলো, আল হেল্প।
স্যার এই যে যেখান থেকে লেখা শুরু করলেন অ্যান্সারটা ওই পার্ট থেকে।
নতুন রেজিস্ট্যান্স হবে হচ্ছে অরিজিনাল ওয়্যার রেজিস্ট্যান্সের অর্ধেক।
আচ্ছা 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 বুঝেছি স্যার। এখন 2 টা বুঝছি, তখন বুঝিনি যে 2 কোথা থেকে আসছে।
আচ্ছা সরি I should have zoomed it a bit more. সো এটা আসলো, এটুকু গেল, এন্ড 120 ওয়াট আসলো। আমার আগের কোশ্চেনে অরিজিনাল কম্পোনেন্টের পাওয়ার ছিল কত? দ্য কোশ্চেন টোল্ড আস দ্যাট দ্য পাওয়ার ওয়াজ 60 ওয়াট, নাও উই হ্যাভ ক্যালকুলেটেড টু বি 120 ওয়াট, সো ইউ সিম্পলি রাইট দ্য পাওয়ার বিকামস ডাবল। এটা সেন্টেন্স এখানে লিখবা, সো পাওয়ার ইজ ডাবলড। দ্যাটস ইট। বুঝে গেছে?
ইয়েস স্যার।
আচ্ছা, এটা লেখার স্টাইলটা দেখালাম এই জন্য যে তোমরা অনেক কিছু কথাবার্তা লেখার চাইতে যদি এরকম ইকুয়েশন দিয়ে লিখো তাহলে খুব অল্প কথায় পারফেক্ট আনসার করে দিতে পারবা। দিস ইজ ভেরি ইম্পর্টেন্ট বিকজ টাইম ইজ অফ এসেন্স, টাইম ইজ নট মানে expandable resource in an exam hall. We're going to the part 2 for this question. It's very simple. I don't see much problem over here. No, I actually see some problem. I want you to attempt question number 20. This is a unique question where diameter has an internal resistance of 5 ohm. So এটা মাথায় রেখে আমাদের কিছু কাজকর্ম করা লাগবে। Already you have to understand that this 5 ohm resistor is just working as a resistor that is currently in series with the ammeter, as you can see in the circuit. So try this whole thing all the way up to D. This is a pretty large question, elaborate question. এই কোশ্চেন নাম্বার 20টা অ্যাটেম্প করো, তারপর আমি হেল্প করতেছি। শুরু থেকে করে যাও। Okay, we're using the recording. In B1 it says that আচ্ছা এটা পারছো তো?
ইয়েস স্যার।
A uniform wire of AB of length 100 cm is connected between the terminals of a cell EMF 1.5 volt and negligible internal resistance as shown in figure 6.1. We have a cell, we have a long distance wire, we have a parallel combination of an ammeter connected over here. An ammeter of internal resistance 5 ohm is connected to the end A of the wire and to a contact C that can be moved around the wire. Determine the reading on the ammeter for the contact C placed. So we have to just understand this circuit in a slightly different way. That's a bit trouble to select the whole thing because it was split into pieces. So can we select the whole question? Okay. So let's have a look. The question says, and from our an emitter of internal resistance 5.0 ohm is connected to end A of the wire and to a contact C that can be moved around the wire. Determine the reading on the emitter on the contact C placed at A. So if we place the contact C at A, so try to visualize this. If we place it right over here, what will be the voltage across the two ends of the emitter?
Sir, 1.5.
How come 1.5? The circuit is this much big. The actual main circuit হচ্ছে এটা, এটা হচ্ছে মেইন সার্কিট যার মধ্যে horizontal ওয়্যারটা হচ্ছে resistance wire. This is the resistance wire through which 1.5 volt would be uniformly distributed over this resistance wire. Now if we connect the slider right over here, so one end of the emitter is connected over here, the other end is also connected at the same point. So what would be the voltage across these 2 points?
0.
0 is a correct response.
0. আচ্ছা
So you just rate 0. Determine, which means you don't have to essentially show any calculation. Then it says what will be the current if you place it at B. Now if you place the contact at B, you have to visualize that the way the circuit is going to work. And let me just redraw the circuit for your understanding. One is 1.5 volt with the whole rectangular thingy. And okay, I don't need that. So this is the resistance wire. So this is the thick resistance wire that we have. And if we connect the ammeter, let's say, just to make sense with the ammeter with a 5 ohm resistor over here, if you connect it over here, practically you can see that this would basically work as if this 1.5 volt is connected in parallel with this branch and also with this branch, ঠিক না? And এই ব্রাঞ্চের টোটাল রেজিস্ট্যান্স আমাদেরকে এখনো বলে নাই, কোথাও বলছে? এই ওয়্যারের ফুল রেজিস্ট্যান্স কোথাও বলছে? বলে নাই. But we know that diameter has a resistance of 5 ohm, which means 5 ohm is connected across 1.5 volts. So current value হবে কত? V by R 1.5 divided by 5 equals to 0.3 ampere. That's basically it. বুঝছো?
Yes, sir.
এরপর কি বলছে? Using the circuit in B, an ammeter reading I record at different lengths of the contact C from the wire. Some data points are 26.2. Use your answers in B to plot data points on 26.2 corresponding to the contact C placed at the end A and B of the wire. So in A তে আমাদের value আসবে 0. So we're going to have one point plotted over here and one other point will be plotted across 0.3, 0.3. So if we place it at 100 centimeters, it's going to be 0.3 right over here. So এখানে একটা point আসবে. Draw the line of best fit. So you have to draw a smooth curve. A smooth curve আঁকার মেথড হচ্ছে, আমি একটু দেখাই, তোমরা আঁকতে পারো, আমি শিওর তোমরা আঁকতে পারো, তোমরা পেপার 4 বা পেপার 3 দিয়ে আসছো, so you know how to draw smooth curve. But in my opinion, the 2 points that we're going to have, one is going to be right over here, so we're going to have one point over here, we're going to have one point right over here. And if we are trying to draw a smooth curve, okay, I cannot actually draw it with this. Try to place your wrist somewhere over here, try to place your wrist somewhere over here so that you can have a smooth hand gesture, or your wrist is gonna, if you place your wrist over here, then you can have an arc movement like that and attempt that arc movement a couple of times and then finalize your hand movement to draw the curve. So do that right now. Make that curve go through all the points, which is actually quite difficult to achieve in this graph, but actually quite easy to make possible in MS Paint. MS Paint has a pretty nice operation to draw curves. So for example, actually, okay, never mind. I'll use this format. So MS Paint has a thing called this one. You can actually try to draw a curve from here to here, and then we can try to curve it as per our requirement like this. So MS Paint is awesome that way. can have it go like this, and I think that pretty much works for the curve. It has a quite linear at the beginning, and then it slowly curve up upwards, and eventually it will meet over here. So গ্রাফটা আঁকো, গ্রাফটা আঁকার পর আমাদের বলছে draw the line of best fit, and then it says that and hence determine the diameter ring for the contact C placed at the midpoint of the wire. So if the contact C, which was this one was placed at the midpoint, which means this value would be 50 centimeter. So from here we just have to find out what is the crossing point for the 50 centimeter and get this reading from here, and you simply write that number over here. That's pretty much it. Then it says further, use your answer to calculate the potential difference between B, A and the contact C for the contact placed at midpoint of B. So এটা ক্যালকুলেট করতে হবে, বাট এই পর্যন্ত আগে করে আসো, দেখো এই রিডিংটা কত হয়, মিলে কিনা দেখো। কার্ভটা আঁকো, রিডিংটা মিলাও, তারপর আমাকে আবার বলো। D number, can we explain, try to have a way to answer this question? That why at the half point, even if it is connected at the half point, halfway point, we do not have what we wanted? Why is it so?
Sir, internal resistance.
No, আমাদের ব্যাটারি ইন্টারনাল রেজিস্ট্যান্স নেগলিজিবল বলেই দিছে, এই যে পড়ো, নেগলিজিবল ইন্টারনাল রেজিস্ট্যান্স। Let me draw this for you. Maybe that will help. Did I draw this a bit earlier? Oh no, that will not work. Let's say here is the 1.5 volt battery cell. So only one. This is the long resistance wire that we have. Naturally, this 1.5 volt would be divided uniformly over this wire. What we have done, we have connected an ammeter that has some internal resistance. So we are drawing the ammeter. I'm drawing this ammeter and also this resistance of 5.0 ohm. And I'm connected exactly at the midpoint, let's say. I want you to see this thing in this version. We have half of the wire's resistance on the left, half of the wire's resistance on the right. We have a 5 ohm resistance over here. And then we have this. সিচুয়েশনটা এরকম না? Do you
Yes,
see it?
sir.
এখন তুমি চিন্তা করো যে for the combination of this type, is the resistance of this whole thing exactly equal to this part? Is it? Which part has smaller resistance?
Sir,
Left part.
first part.
The left part. So because it has a less resistance, it is causing a less voltage than the half. এই কথাটা তোমাকে ভাষা টাষা দিয়ে গুছায় লিখতে হবে। So if I was answering this question, let me see how much mark do we have? We have 2 mark over here. If I was answering this question, I would write it this way. The connected ammeter produces a parallel combination with the left half of the wire, or you can, if you do not use the term left, you can say that the connected ammeter produces a parallel combination with the AC part of the wire. So the combined resistance of half the wire and the parallel combination of 5 ohm ammeter is less than the CB part of the wire. Less resistance gives us less voltage. That's why the value is not half. আমি অনেক কথা বলে ফেলছি, অ্যাকচুয়ালি এত কথা বলা ঠিক না, আরো প্রিসাইজলি লেখা পসিবল। ইফ ইউ থিঙ্ক অ্যাবাউট ইট, ইউ ক্যান মেক ইট প্রিসাইজ, বাট ডিড ইউ গেট মাই পয়েন্ট?
Yes, sir.
Yes, sir.
সো আমরা একটু মাস্কিমের ল্যাঙ্গুয়েজটা দেখি বুঝার জন্য। Circuit acts as a potential divider or current divider, so current in AC is not the same as current in BC. Okay. Resistance between AC is not equal to resistance between C and B, or current in wire AC into R is not equal to current in wire into BC into R. So I did not actually say the first statement, but I definitely covered the remaining two. So I said these two
Sir, it didn't talk about the lower resistance part.
Which one?
স্যার ওই যে প্যারালালে যে স্যার রেজিস্ট্যান্স কম থাকবে স্যার ওইটা তো মানে মেনশন করেনি স্যার।
হ্যাঁ, ওইটা তো বলছে যে resistance between AC is not equal to resistance between C and B, and I said resistance of AC would be lower than resistance of CB, which basically means the same thing, but my information is more informative than this one. In this case, stating not equal scores you the mark. If I say something is smaller than the other one, that essentially inherently implies they are not equal. বুঝছো কি বলছে?
Yes sir.
That can be considered to be synonymous and mark scoring as well. So আমরা যদি examination reportটা দেখি, ডিতে বলছে very few candidates, let me zoom in a bit, this is the D number, very few candidates were able to score any marks for this part. The effect of the resistance of the emitter of the on the total resistance for the section of the wire was not spotted by all but a small number of candidates. Few realized that these resistances were in parallel for the section of the wire. The majority of the answers refer to the resistance of the wire, seating effects, internal resistance, blah blah blah. See what I mean?
Yes sir.
Yes, sir.
আচ্ছা, আমরা তো পরেরটা একটু ট্রাই করি তাহলে।
স্যার,
জি বলো।
আমাকে কি আপনি B2 টা আরেকবার বুঝাইতে পারবেন প্লিজ?
B2,
জি।
B2 তে বলছে determine the reading on the ammeter for the contact C placed at A, placed at B. So that's basically placing the contact over here. Have a look how much, I mean, the current is going to come out here, flows through here, one part goes through here, one part goes through here, and these two are in parallel, and this goes all the way back. So what is the voltage applied across this 5 ohm resistor within this branch, second branch, lower branch, when this end is connected exactly at this very last point? So what is the voltage available for this 5 ohm resistor?
স্যার 1.5, কিন্তু আমি বুঝি নাই কেন।
Because they are in parallel. Have a look, এই যে কারেন্ট আসতেছে, একটা কারেন্ট এদিকে যাচ্ছে আর একটা কারেন্ট এদিকে যাচ্ছে, দুটো কারেন্ট আবার এখানে এসে মার্জ হচ্ছে, তারপর আবার ফুল কারেন্ট এদিকে ফ্লো করে চলে যাচ্ছে। তাহলে আমার এই ব্রাঞ্চটা আর এই ব্রাঞ্চটা প্যারালাল হলো না? প্যারালাল ব্রাঞ্চে
Yes,
ভোল্টেজ
sir.
সেম থাকে।
বুঝেছি স্যার।
Beautiful. আচ্ছা, 21 একটা খুব ভালো কোশ্চেন। 21টা তোমরা একটু ট্রাই করো। 21টা খুব ডিফিকাল্ট না, বাট ইটস এ গুড কোশ্চেন। সিরিজ এবং প্যারালালের কিছু কাবজাব আছে, এটা করতে পারলে ভালো হবে, কারণ এই টাইপের কোশ্চেন পরীক্ষায় আসে। একটা ভালো মতন বুঝতে পারলে সবই করতে পারবা। 21টা ট্রাই করো সবাই। I'll pause the recording, give you some time. After 21, please try 22, because here we have some good calculations about power and also a good graph where we have to do some scaling. So it's pretty important. Attempt these two as well.
আজকে রাত্রেও কি ক্লাস হবে?
আজকে কি বার? শনিবার রাতে। হ্যাঁ, শনিবার রাতে রেগুলার ক্লাস রাতে টাইমে হবে 7:30 না?
জি স্যার।
হ্যাঁ,
জি
ওটা নিব
স্যার।
ইনশাআল্লাহ। The moment we start flowing current through the filament lamp and it starts to glow, from that instance of allowing the current, the filament is going to start to heat up, and that's how it will start to glow. So the temperature will increase. As the temperature increases, you will definitely have a subsequent increase of resistance, not proportional, but it will increase. So if resistance increases, you cannot have a straight line graph. A filament lamp, metal piece, metal filament, is not an ohmic conductor. With temperature, its resistance gets significantly affected. ঠিক না?
ইয়েস স্যার।
সো তাহলে এটা আমরা কিভাবে আঁকবো? আমি গ্রাফটা এঁকে নেই। আমাদের ভ্যালু দেওয়া আছে 12 volt 36 watt. So at 36 watt, which is the rated power, under 12 volt, the current would be 12 volt 36 watt, which means this is operating condition. 12 volt apply করলে আমরা 36 watt পাবো। তার মানে আমরা যদি P equals to VI equation থেকে I টাকে ক্যালকুলেট করি, we're going to get P by V. So 36 divided by 12 gives us 3 ampere, which means whenever we are going to apply 12 volt, we're going to get a current of 3 ampere. So let's count how many divisions do we have. 1, 2, 3, 4, 5, 6. Pretty convenient. So 3.0. So this would be 1.0, 2.0, 2.5, 1.5, 0.5. And then you just know only one point, সেটা হচ্ছে 12 ভোল্টের জন্য পারফেক্টলি 3 তে এসে শেষ হবে। And কথা হচ্ছে এক্সামিনার তোমাকে যে পয়েন্টের যে জিনিসটা জাজ করবে সেটা হচ্ছে the examiner is going to look that did you draw a decreasing gradient curve or not. So make sure that you draw a decreasing gradient curve as best as you can, but do make sure that this curve, because of the decreasing gradient, doesn't look like this. Do not make it apparently horizontal at the end. This would be wrong. It will be losing gradient, but it will never become horizontal. So don't make it to become flat out, visibly flat out at the end. Decreasing gradient, but decreasing gradient. That's it. বুঝে গেছে?
জি স্যার।
Beautiful. B number is the part we actually saw the calculation mechanism for power calculation for one of the earlier questions. Try to apply that ideology or mechanism for your requirements. So, and then for B3 I'll help you, definitely I'll help you for B3, but 1 and 2 I want you to try and solve on your own. B1 তো পারছো, B1 এর আনসার কত?
2 kilowatts.
2 kilowatts, no big deal. এখানে কত হবে? half kilowatt. আমি এটা ইয়া করে বের করে নেই যাতে করে আমাদের বুঝাতে সুবিধা হয়। So এখানে আমরা যদি দেখি সেটা হচ্ছে যে we are having a voltage sharing. So the power of one of this component would be P equals to actually I can write the given information was for 230 volt we're gonna have 1.0 kilowatt. That was the equation. Answer already kilowatt দেওয়া আছে, so we don't have to write the unit. So the resistance is pretty same. So P equals to V square by R. For a constant resistance, we can write P proportional to V square. You don't actually have to show all of these stuffs. You can simply write this value and move on, and you will get 1 mark for that anyway. I'm just showing you how to do this, which would mean that P1 by P2 should be equals to V1 square by V2 square. And within this case, for the given scenario, whenever we are applying 230 volt full, we should get a power of 1.0 kilowatt. So if we're applying half of that voltage, so we are currently calculating for one heating element, not both of them. So if we apply 115 squared, what power are you gonna get? So the new power we're gonna get will be 0.25 kilowatt. That's the power we're gonna get out of this thing. So one of the heating element gives you 0.25, two of them simultaneously or together gives double of that, that is 0.5 kilowatt. That's it. এই ক্যালকুলেশন দেখানোটা বাধ্যতামূলক না, এই ক্যালকুলেশনটা তোমাদেরকে বোঝানোর জন্য আমি দেখাচ্ছি। This is shown for your better understanding. What happens here? For this case, you just have to calculate all the voltage distribution very carefully. Just by looking at this circuit, how would you define this circuit? Number 3. How do you describe this circuit? Let's say if I name them, let's say A, B, and C. How would you describe this circuit?
B and C are in parallel, connected in series with A.
Precisely. B and C are in parallel, and that parallel combination is connected in series with A. Which means if you consider 230 volt, if you try to judge, the common resistance of this whole thing will be, let's say, R by 2, and this one will have a resistance of R. So the voltage will be divided in the ratio of R by 2 is to R. A ratio te bhag hobe. That is basically half is to 1, or I can write 2 is to 1. So this whole parallel combination is gonna get 2/3 of the whole supply. Let me lift it up. This parallel combination is gonna get 2/3 into 230 volts, and the series component is gonna get 1/3 into 230 volts. So calculate that out. How much do you get? This is gonna be something. This is gonna be something. এটা কত হয় দেখো তো। Actually এটা বাইর না করলেও সমস্যা নেই। Disregard that. এটা বাইনা করলে সমস্যা নেই, সমস্যা আছে, সমস্যা নেই, সমস্যা নেই। So we can now calculate what would be the total power of this whole thing. I mean, this whole resistor is essentially having a voltage of this much, whatever we get over here. আচ্ছা ক্যালকুলেট করে ফেলি, সমস্যা নেই। আচ্ছা calculate-
1:2 হবে না?
সরি, হ্যাঁ ভুল লিখছি, হায় হায় বিশাল ভুল করে ফেলছি। 1:2. So the parallel combination should get 1/3 into 230 volt, and the series combination is gonna get 2/3 into 230 volt. Thank you, Zari. So we don't essentially have to do the whole thing. We can simply calculate how much would be the power generator over here, because we are now made available 1/3 of 230 volt. We just saw earlier that P proportional to V squared. So when V becomes V by 3, P becomes P by 9. ঠিক না? Because there is a squared, which means this one's power will be 1/9 of 0.1 or 1/9 of 1 kilowatt. This one's power will be 1/9 of 1 kilowatt, and this one's power would be for this one we have actually applied 2/3 of the voltage. So because P proportional to V square, so whenever V is made into 2/3 of V, then the power should become 4/9 of that power. Just square that fraction. So this one's power would be 4/9 of 1.0 kilowatt. So now we add all of this value, 1/9 plus 1/9 plus 4/9 into 1.0 kilowatt, and calculate how much do you get. This would be, I think, 6/9, 1.0 kilowatt. So that gives you how much? 0.67 kilowatt. Yep. এটা ক্যালকুলেট করা আরো সহজ বুদ্ধি আছে, বাট দ্যাট ইজ আ বিট কনসাইজ, ওই জন্য আমি ওটা দেখাচ্ছি না। First, you have a look at this whole thing and try to understand what I did over here. এটা বুঝা গেছে কিনা দেখো। এই হিসাবটা সব বুঝা গেছে? There is a different way to achieve this. The different way to achieve this is like this. The shortcut way. Shortcut way হচ্ছে এরকম, দেখো বেসিক আইডিয়াটা হচ্ছে, if we had a 230 volt supply connected with one of the filament, one of the heating element, this one would have a power of 1.0 kilowatt. এটা ছিল basic case. So assuming that the resistors of this resistors are, what will be the combined resistors of this whole combination? If পুরো combination এর resistors কত হবে? R by 2 plus R, which means 1.5 R. ঠিক না? এটা কি বুঝতেছো? Same voltage is applied across a different resistor. The combined resistance of this whole thing is 1.5 R. এই হিসাবটা বুঝাচ্ছে কিনা দেখো। বলবান?
জি স্যার, বুঝা যাচ্ছে।
Yes, sir.
ঠিক আছে? এখন তুমি যদি P equals to V square by R জাজ করো, এখন আমি জিনিসটা করবো সেটা যে ভোল্টেজ সাপ্লাই যদি দুটো কেসে সেম, এখানে 230 ভোল্ট, এখানে 230, forget about this one. I mistakenly circle this. ভোল্টেজ সাপ্লাই আমাদের সেম, এটা 230 ভোল্ট, এটা 230 ভোল্ট, শুধু রেজিস্ট্যান্স দুটো ডিফারেন্ট হচ্ছে। তার মানে আমি V স্কয়ারটাকে কনস্ট্যান্ট ধরলে P proportional to 1/R, তার মানে হচ্ছে P1R1 equals to P2R2. And the value also, for the first case we had a power of 1.0 kilowatt, the resistance was only R. For the second case we are trying to calculate the power, and the new resistance is up to 1.5 R. Now if you R and R crosses out from each other, if you do the side change, P2 equals to 0.67 kilowatt. This is a much simpler way, much too simpler way, but here you have to think a bit out of the box because you have to consider the supply to be constant and the resistances were considered to be variables. এইভাবে করলেও হবে কারণ এই কোশ্চেনের জন্য ফুল ওয়ার্কিং এর জন্য আসলে খুব ওয়ার্কিং শো করার জন্য খুব বেশি মার্কস নাই writing being able to write the final correct answer is pretty much what scores you the mark. If you have a look at the mark scheme, this was question number 22. It says what total resistance is 3R by 2, power equals to 167 kilowatt. That's it. That's what they did. So they are expecting a representation of total resistance of 3R by 2. The mark scheme exam report says there are very few correct answers. All three calculations proved to be difficult for most candidates. The calculations of the power dissipation in resistors when the resistors are counted across the power supply is straightforward, parallel, or series combinations was found to be particularly difficult. So power calculation for most of the students proved out to be difficult in general. That's the general comment for the examiners. It can be difficult if you don't understand what to take constant and how to approach the circuit. But if you understand, like for example, in this case, if you have a look over here, I consider the supply to be constant and resistance was the variable for which I went through. Whereas for in this calculation, I actually went through the whole facade. I calculated what would be the individual power of the heating elements, 1/9, 1/9, and 4/9, depending upon how the available voltage changed. Then I summed all of those individual changes and calculated the total power of the whole system. So this is a much more, what can I say, much more dissected version of the whole calculation, whereas this one is a overall more simplified and far more simplified version of the same calculation. Any questions so far?
No, sir.
আচ্ছা এরপর আমাদের আরো কিছু প্রবলেম আছে এই বাকি প্রবলেমগুলো ইনশাআল্লাহ আমরা আজকে রাতে আবার দেখবো ফর দ্য টাইমে আমি ক্লাস ক্লোজ করে দিচ্ছি আজকে এটুকু থাক এখন এই মুহূর্তের জন্য আজকের জন্য এটুকু থাক
আল্লাহ হাফেজ স্যার।
Thank
ওকে স্যার, আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম তোমাদের আগে ভিডিওগুলো সব আপ করে দিছি দেখো
স্যার কালকেরটা করে দিয়েছিলাম। আচ্ছা।